So today we are going to be going over exponents. So we should have seen exponents all the way back to pre-algebra. And they also come up in Algebra 1 and Algebra 2. But for some of us, it's been a little bit. So we're going to review some of those exponent properties. Now, remember, with our exponents, when we're talking about exponents, we have two different parts. We have the number on the bottom, which is our base, and we have the number on top, which is our exponent. Most of the properties that we're looking at require that we have two things that have the same base. So in number 1, we have a to the m times a to the n. So notice that our base for both of those is a. And when we multiply two things that have the same base, we add our exponents. Very similarly, on number 2, when we divide two things that have the same base, we subtract our exponents. Another important property is when we have a negative exponent, it's going to turn that into a fraction and put that in the denominator. Now notice that it does not change the overall sign. My fraction is still positive. So when that negative is in the exponent, it does not make it a negative number. Another important property is anything to the 0 power is going to be 1. So make sure that we don't get that confused and say that something to the 0 power is 0. It will always be 1 as long as we're not talking about 0 to the 0 power. So then also remember that we can kind of think about our exponent as being able to distribute as long as we have multiplication, like in number 5, or division, like in number 7. So we can kind of think of it like distributing it or applying it to both parts. So we have a times b quantity to the m power, and we can switch that to a to the m times b to the m. Likewise, when we have division, that changes into a to the m divided by b to the m. On number 6, anytime that we raise a power to another power, we multiply those two powers. And lastly, this one doesn't come up as much, but on number 8, if we have an exponent of 2 and we have absolute values, we can take that squared outside of the absolute values. So let's look at some examples with our exponent properties. Our instructions say rewrite each expression with positive exponents. So on our first example, we have so we have x to the negative first. So remember that our property said that when we have a negative exponent, it's going to bring it into the denominator and change that exponent to be positive. So instead we have 1 divided by x to the first, but because it's the first power, we can go ahead and just rewrite that as x. Now, looking at that problem, I don't have anything else that I can simplify. I have all positive exponents, and so we did what the instructions asked us to do, so that is my final answer. On question number B, I have 1 divided by 3x to the negative second. Again, we have a negative exponent, but notice this time we have two different parts. That negative is only being applied to the x. So I'm going to break apart into two separate fractions, which as long as we keep my numerators the same, we're okay. So I have 1/3 times 1 divided by x to the negative second. So using that same property that we used before, I'm going to rewrite that denominator as 1 divided by x squared. But hopefully we notice that that is not a super pretty fraction. I have 1 divided by 1 divided by x squared, which if we recall is also called a complex fraction. So when we have a fraction within a fraction, It's a complex fraction, kind of like fraction inception. And we don't want to leave it written like that. So the way that we're going to simplify that is we keep the top. So my numerator, the biggest numerator, is just 1. Then we're going to multiply by the reciprocal of the denominator. So my denominator, the biggest denominator, is 1 divided by x squared. And we want to take the reciprocal of that. So remember that a reciprocal is just flipping the fraction. So instead of 1 divided by x squared, we get x squared divided by 1. So we keep it, we change it, and then we flip it. So keep the numerator, change to multiplication, and flip the denominator. And then I can just multiply straight across. So 1 times x squared gives me x squared on top. 3 times 1 gives me a 3 on bottom. Now, in the future, instead of rewriting it as a complex fraction, you can go ahead and say, oh, I have a negative in my denominator. That's going to move it to the numerator with a positive exponent. Do be careful though, because this -2 only applies to the x, not to the 3. If it was going to apply to both of them, it would need parentheses, which is why my 3 stays in the bottom the entire way through my problem. Again, checking, making sure there's nothing else that will simplify, and we now have positive exponents, so that's going to be my final answer. On part C, we have 12a cubed b to the -4th divided by 4a to the -2nd times b. So starting with just our numbers, we have 12 divided by 4, which gives us 3. Now, looking at our next parts, we actually have 2 different sets of common bases. And recall that when we have division, we're going to subtract those exponents. So we have 3 minus a -2 on the exponent of our a. Then for our b, we have -4 minus, and because we don't have an exponent there, it's an understood 1. So then simplifying, we end up with 3 times a. We have 3 minus a -2, so it ends up being 3 plus 2. So we have a 5th power. And then for our b, we have -4 minus 1, which gives us a -5. Be careful, because we've done a lot of steps, and so some of us would just forget and say, oh no, now we're done. But we're not, because our instructions say rewrite each expression with positive exponents, and my b still has a negative exponent. So we need one last step. So we have 3a to the 5th. We move our b value down to the bottom, and we get 3a to the 5th divided by b to the 5th. So now that they're all positive, that would be our final answer. Lastly, we have 3x squared divided by y, all raised to the -2nd power. So because we have a big parentheses here, that means that the entire thing is being raised to the second. So again, we can kind of think about it like distributing it. So we're going to distribute that -2nd to the top and to the bottom. Now be careful, because now that my numerator is in parentheses, that -2 applies to both the 3 and the x squared. So we have 3 to the -2nd times x squared to the -2nd. So remember, we multiply when we raise a power to another power. So we'll have x to the -4th. And then in our denominator, we just have y to the -2nd. So now we need to simplify. So recall, like we said in example B, because we have a negative in our denominator, we could go through all of the steps of switching it to be a complex fraction, but it's going to end up just moving it to the numerator. So that y to the -2nd is going to become y squared in the numerator. divided by, I'm going to have 3 squared times x to the 4th. And then our last step is just going to be to square that 3. So we get y squared divided by 9 times x to the 4th. Again, checking and making sure that there's nothing else that can be simplified, and making sure that we now have positive exponents, which we do. So that is going to be our final answer.